Good evening, everybody. This right here is a tiny dynamic quadruped robot I built in my bedroom. His or hers or whoever's name is Sesame, and I have three different versions here, the regular size and the Sesame Micro. But I guess for a little bit of context, I should tell you about myself. My name is Dorian Todd, and I am a mechanical engineering undergraduate at San Jose State University. I'm entering my second year as an undergraduate, so still learning, but having opportunities like this has been a really big push in spreading information about the stuff that I do. For a little bit more context, I like robots, and I've liked robots for quite a while. This is me at 6 playing with one of my first ever robot toys, and it was an absolute blast, and honestly, I think this is part of the reason I have so much of an interest in these topics. Some of the projects that I do are a little bit unique. They aren't the robot systems you think you might see. A great example of this is my autonomous hexapod system called Red Hex. Red Hex is a system built on top of a 6-legged robot that uses a 3D scanner mounted to its head to detect people in a field. It's essentially looking for humans and detecting them and then chasing after them at full speed. And there are definitely moral questions with this entire project, but what I found is that even if I didn't have some save the world goal with the project, I was still able to learn a ton from that. Another great example of something like that is PenBot Mini. This is a linkage-based drawing plotter, which is a little different from like any other robot because it's using these little arms attached to motors to move a Sharpie or a pen around a paper. The entire robot fits inside of the footprint of a credit card, which was one of the big design restrictions. And so this entire project I was thinking, none of this is required to do a good drawing robot. In fact, there are proven solutions that are significantly better than what I was trying to do. But what I learned from doing this is that you don't have to take the easiest route to get a result. And in fact, if you take a harder route, you might end up learning a lot more from the project. And then, of course, there's the Sesame Robot Project, as I introduced with these little guys, which has been one of my most successful projects in terms of people viewing it and seeing it. I think that every project starts with a question, and those questions are really special because they come from a place that we've developed over the course of our entire lives. As a kid, we had all of these questions for our parents that they thought were just maybe stupid at times, where you just always asked why, and a lot of people have kind of stopped asking why. But when you take the chance and do, you end up with a lot of interesting questions. For me, a lot of those questions started from places that I had been as a kid. I went every single year to an event called Maker Faire, and you guys might be familiar. I know they host some of those here. But my parents took me like every year. Without fail, we would forget Christmas sometimes, but Maker Faire, you had to go to that every year. And so I would go to these things and I would see, for instance, this line following robot, and I would just think, why or how? And those questions, they built up over time. Having opportunities like this and meeting awesome people, for instance, this is Adam Savage, if you've ever watched the Mythbusters. We got to see this guy every year, and it was an honor and a privilege, but it gave me these opportunities to say, hey, I saw this cool stuff that year, and now I'm working on my own cool thing. And just seeing that as a community was really, really beneficial in growing and asking questions. That led me to Fusion 360. You see, you can have lots of ideas, but without tools to act on them, they end up kind of falling flat or just not coming to fruition. And so as I was growing up, I kept asking, what can I use to act on these ideas? And one of those tools was Fusion 360, which is a CAD design software. CAD stands for computer-aided design, and it's essentially like, let's say, Blender or some other 3D modeling program that allows you to make accurate models of the things in your head. And it's this way of translating all of these ideas into real-life creations. So learning this was almost the biggest catalyst for me in enabling me to create projects. And that leads me to this, which may seem completely unrelated, but there's this website called Bilibili. And it's almost like a Chinese version of YouTube. And it's really fun, but it's really weird. And I had seen this little robot on there, and I had all these questions about making and engineering that had built up over my childhood. And I had this skill learning in Fusion 360. And at the precipice of all of these things coming together, I see this video on this random Chinese website that I probably wasn't even allowed to be on, being someone from the US. And I see it and I go, I want to build that. And kind of for the first time, I thought, I have the skills at this point to try it. But there was a problem, because the original creator of this design didn't publish any of the files. And even if he did, a lot of them were region locked. So no Americans allowed, which was unfortunate for me because I really wanted to try and build this project. Then I thought, what if I just build it from scratch? At this point, I had grown the ambition to just try things. And as you'll see, it's really important that sometimes you just bite the bullet and try it. And that's exactly what I did. And so I started to design the Sesame Robot Project. And at that point, I can't remember what I was calling it. I think the name of the file was called littleguy.fusion360. And there was just no through line. There wasn't any plan, but I knew that I had this reference and I wanted to build something cool. And I just started designing. While I was designing, I thought to myself, if there was another Dorian out there with the same mindset and the same perspective who saw my project, if I ever published it, and they ran into those same roadblocks where there just wasn't files available or documentation, then they would be incredibly disappointed. So while I was designing and prototyping this project, I kept going back to this idea of I should write things down, I should take pictures, I should record my process, and I should get it ready for some other person. And at this point, I had no idea if anybody would see it. Honestly, I was pretty sure nobody was going to see it, but I knew that if one person did, then I would be satisfied because I would have helped that person, see through with their vision. That being said, I set all these project goals as a result of that ambition. And at this point, I had no idea if anybody was seeing it, so there was kind of a bit of me being ambitious setting these goals. Number one goal was to keep the cost as low as possible. Makers aren't millionaires. They don't have these crazy budgets to do design and development. So if I wanted to keep the robot accessible and available to people, I needed to keep the cost low. I also wanted to make the robot dynamic and expressive. In that original video I watched on the Chinese website, it was dancing around. It was doing incredible things, and that's one of the reasons it was so interesting. And so I needed to preserve that expression that it had. And then I also wanted good documentation and resources. Like I said before, if someone had found this project and they were just as disappointed as I was when I found that original project, then I would fail. The result of setting these ambitious goals was over 120 revisions to reach those goals. Those 120 revisions were modeling something, manufacturing it through 3D printing, testing it, and then going back in. If I had to put a number on it, it'd probably be around 300 hours of design and development just to get to a spot where I was comfortable publishing it. At the same time, I was recording all of this, and in high school I had learned how to video edit, so there was kind of this mixture of multimedia that I was able to put together. And so I had produced this kind of video with it. And through producing that, I would kind of encounter these moments in the design where I'm like, well, this worked, but would it work for someone else? And through those thoughts, I encountered a lot of design points. And a great example of this is the hip joint of the robot. This specific part was designed for my 3D printer. And when you think about publishing something and someone else downloading it, they have different equipment than you do. And so with this particular piece, I changed everything about it so that it would print perfectly on this flat face on the front here. And there was all of these minor tweaks and design changes that were enabled by the fact that I realized I was actually making something that people might see. And through editing that video, I was like, hey, I actually, I'll watch it back in the timeline and I'll say, this is actually okay. Someone might eventually see this. But at the same time, I was like, expectations are at the floor. The bar is as low as possible. There was another issue where there was just a ton of wires inside of the robot. And this problem persisted even past when people started seeing the project. And it kind of becomes this bundled mess where you're trying to press the robot closed and everything. And as the project continued, I kept looking back at this issue and thinking, this needs a solution. And so I brute forced learning PCB design, which is as hard as it sounds. I essentially learned how to do electrical engineering for design of circuit boards through YouTube and watching YouTube videos. And by doing that, I was able to create the V3 PCB over the course of V1 and V2, which we don't talk about because they were explosive failures. But that's kind of an important note about this is you're not going to get it right on V1 or V2. And that's totally fine. Sesame is on V121 now. And those files just got published a couple days ago. And that's kind of the beauty of projects like this. They aren't necessarily ever done, but if you have the guts to put them out there, then they could turn into something. Regardless, I made some tools. And since Sesame and the project around it didn't necessarily have an industry standard because I was kind of just building all of this stuff in my room, I was the one who had to make the industry standard for this robot. Those tools included Sesame Simulator, which is a simulation app for driving the robot in your computer instead of in person. And I built this out of fear that I would destroy all of my hardware because the first 3 tiny quadruped Sesame robots broke themselves because I put in the wrong command and they moved their leg and it just exploded. And then there's Sesame Studio, which is an animation suite that I built for the robot. I realized if I wanted to get that creative expression that I had set as a goal in the beginning, then I was going to need to animate all of the emotions and emotes, and there was no tool for that. And so I built Sesame Studio, which is a stop-motion animation suite for this robot specifically. And then finally, there's the Sesame Companion app, which is basically if ChatGPT could control the robot, which was kind of this interesting thought experiment where I wanted to integrate talking to the robot as a feature. And I really am not fond of ChatGPT and how it talks to you. So I literally spent months making it as dumb as possible. And so in this software is hard-coded rules that say you're not allowed to be smart, and you have to be friendly, and you have to be this certain personality. And all of that programming got me this really endearing creature. And I went and used a really old voice generator from Windows XP days, so that really feels like a robot. One of the things I've been talking about in the few days that I've been here is that robots shouldn't pretend to be human. It immediately breaks this trust that you have with them, especially with a cute robot. Once it starts acting and talking like you're like, hold up, you are not a human. Let's not cross that line. And so through that, I was able to get this sort of expression. And at a certain point, it still did kind of feel like a chatbot. And that's where a bunch of additional programming came in. What I did is every piece of audio generated by the robot would have a waveform. And at the peaks of the waveform, I would trigger an animation on the face so that the face would move its mouth open and close in sync with its talking. And that did wonders to make you think that it's actually talking. And so that was pretty great. Now, eventually, I had to bite the bullet and post the video, because I had edited it and I had published all of this software on my GitHub repository, and I had done all of this work on the project, not knowing if anyone was going to see it. And so I finally put it out there, and it did great. It did 645,000 views in a little over 4 months, and I wasn't expecting any of this. I put it out there thinking, if 50 people saw it, it would be great. And then 500,000 people saw it, and then 600. And it was just kind of this moment where it was like, I've shown that I put a lot of work into this project. And I wanted it to be something that someone could see and be excited by. And the fact that that did come true, and people did see it and get excited by, it really felt like this moment where I felt that not only people who are passionate about robotics can do something like this or try something like this. But it really applies to a lot of different fields. I've seen passion projects turn into million-dollar films. I mean, I imagine you guys have watched all of the indie films coming out in theaters in the last few months. And I think we're at a point where the tools are there for you to be the creative person who is building the creative things and inspiring the creative people. Along with the video going very viral, I guess. I don't like using that word, but the repository also got a lot of interest. And a repository is like the nerdiest place to be popular on. If you have more than 1,000 stars, like you get onto this like elite list of repositories that all of the coders are talking about, and they put you in like forums or whatever. And so we got 2.8 thousand stars, which was this big moment because it's validation. It's showing that people who aren't just there to see it and be entertained by it are looking at it. And they're thinking, I want to build this into something. And this also was shown through our community Discord. Maybe a month or two after I launched the video, people were like demanding me to make a Discord server. And I was like, I don't want to be a moderator. Let's not go there. But I eventually did do it. And it's been this amazing place where people will take pictures of their Sesame on like the hills of Denmark with mountains in the background. And I'm like, wow, this is more global than I thought it was. And people inventing their own versions. I saw recently someone had completely converted all of the body pieces into Rocky from Project Hail Mary. And they had the entire like robot themed around it, and they put a speaker in its face and like made it say amaze and stuff. And it was this really beautiful moment, and that happened just a couple of days ago. And I'll see these projects all the time where they cut it in half, add another pair of legs, and write a whole research paper about it. And it sort of builds itself into this community, which I think is really great. And I think this as a whole speaks a lot for the kind of themes around open source hardware. If you're not familiar, open source is kind of the backbone of a lot of the tech that we take for granted today. Almost every single computer in the world that runs servers and maybe even your phone is running on something called the Linux kernel. And I'm sure you've heard of Linux because of some nerd, but it really is the backbone of a lot of technology today, and it is 100% open source. Every single person who works on those pieces of software isn't paid. They do it because they're genuinely passionate about this project, and it has become something that a lot of us rely on every single day. And I think there's a beauty in having a project that isn't necessarily research. It isn't necessarily corporate, but it is changing things. And it's making things more accessible, and it's contributed to by a lot of people. I'd like to do a live demo, and I dearly hope they work. And I'll boot this one on because it's newest and it's already on. So the way that Sesame communicates with a computer is that it has its own Wi-Fi network. And that's really unique because it means you don't need an app. So no matter your phone, no matter your operating system, laptop, whatever, all you have to do is go to your Wi-Fi networks, like I'm doing here, and then see Green Sesame is a Wi-Fi network. And this is like a router, and it's broadcasting its own network. And then I've basically hacked the sign-in page to be a controller. And so this controller is just like where you would type in the password to the hotel Wi-Fi, but instead all of that data is live transferred to the robot. Yeah, so these guys have all of these pre-programmed emotes, but I've made everything available for people to make their own versions of the expressions. A lot of people have added a emote where it'll lift its back leg and then like shake it a little. And I think they're going for it peeing, but I don't know. It's a little strange. Yeah, there's all this awesome stuff it can do. And there's a whole story about how I miniaturized it into Sesame Micro. And it was a whole hassle. But the entire project is based around these core principles: accessible, cheap, open source. And that makes it so that almost anyone can build it. I have a number of people who have reached out saying, you know, my 6-year-old kid built one of these. And I'm like, that's really impressive, and it's really exciting that people who may not have any experience in the field are getting this exposure to project-based learning. I talked with a group of teachers earlier this week, and a lot of them expressed a struggle with getting their students passionate about things. And I think passion isn't necessarily something that can be taught, but it is something that can be trained. And through training that is catering to people's interests. If people like cute things, give them a cute project. If people like things that are heavy metal, then make them build a guitar. In high school, I built a number of guitars, and it was one of the reasons I learned about frequencies and audio technology. And I may not apply that to my job in the future, but through learning that, I've learned many other topics. So I think there's a lot to be said about integrating projects as an education resource. So that is my presentation. Thank you guys so much for watching. If you want to contact me, there's my QR code, but that's about it. I will also answer literally any questions. It could be about the robot, the presentation, about me, about all the fires I started in my parents' house, but it could be about anything.
How was the PCB design process? How was learning that?
Yeah, so as much as I made it sound scary, PCB design isn't actually that hard. It's more about understanding these core principles about electronics. What a resistor is, what a capacitor is, what they do. And you can learn that in an Electronics 101 class or on YouTube or whatever. But once you have that basis, it's then just about understanding what the software you're using is. I use Easy EDA, but you can use any other software. And it is really similar to just drawing a circuit on a piece of paper. You have your main modules, your capacitors, and whatever else, and you're just drawing the connections between them. And I think a great way to start to learn something like that is to physically wire things. A lot of the original versions of this robot were physically wired with a jumper wire from this location to the next. And by doing that, I kind of had this understanding of the circuit that let me translate it into the computer pretty quickly.
I don't know if you mentioned this, but is there a specific reason you designed them to look this way, or was that just the most convenient way?
So there was that initial design on that Chinese website that I had showed at the very start. You might not have seen it, but it was kind of a basis for a reference. But then I was like, okay, well, I want a screen on the front. I want to be able to show faces. But then I also need to capture all of the wires in a shell. And so it naturally built itself out to look this way. I also have versions with cat ears and bunny ears and tails and stuff. Someone made a dragon version.